So phosphorus levels. Basically, a town has got two sources of phosphorus, which is giving growth to a blue-green algal bloom of their main water source. So to stop this, they need to shut down one of the sources of phosphorus. The student's goal is to find out which source is contributing to more phosphorus per day, and the question gives them both sources, how much water they discharge in megalitres, and at what concentration that phosphorus is distributed at. The first thing you'd expect the students to do to complete the question is identify the known information. So A, they know that 1 megalitre equals 1 million litres. B, they know Johnston's abattoir discharges 5 megalitres at a concentration of 10 milligrams per litre. And C, Arvon discharges 200 megalitres at a concentration of 0.2 milligrams per litre. The next stage is to use the identified conversion factor to convert each water source's megalitre output into litres per day. That's done by using the conversion factor seen. The next step in the solution is to create an equation for the output of water for each water source. So you'd expect your students to have subtitles for each water source. So Johnston's abattoir. First, they would let V be the total volume of phosphorus, or students would allocate a different pronumeral for that value, and T is the time in days. So they know the phosphorus output is equal to the amount of litres outputted times by the time, so whether it's day 1, 2, 3, or 4, and then they times that by the concentration of phosphorus. They would do this for the Avon River as well. The next step of the solution is to solve the equations according to the time that they were wanting. So the question outlined that it wanted the phosphorus concentration per day. So they would substitute T for 1, as it's 1 day, and then they would solve that equation. So next, students want to verify their understanding of the question. This is done by graphing the equations. First step of graphing the equation is they need to rewrite the equation so that it is a linear equation. So that requires them to multiply the last bit of their equation out. So for Avon, they would multiply 0.2 out into their equation. Next, the students would find the x and y intercepts using their knowledge of linear equations, so substituting in 0 for the y value if they want to find the x-intercept, and if they want to find the y-intercept, they would let x equals 0. The next stage, because this linear equation does not have a c value on the end, they would find a second set of coordinates by letting their x value, which is t for time, equal 1. This will get them a second set of coordinates. Once they plot the two coordinates, students would be expected to rule a straight line through them and label the straight line with the equation. I've completed this in Excel just for viewing purposes. As you can see, both equations are labeled. It's expected for an A-level student to also apply and present a algebraic proof. So for their evidence of solutions, they would substitute the solved V into the original equation and solve for T and see if these corresponds. And the last stage, if that all corresponds, is the students would state the conclusion. So by using the proofs, the algebraic solutions and graphical solution are proven correct. Therefore, Johnston's abattoir contributes to more phosphorus per day than Avon River, as 50 million milligrams is more than 40 million milligrams.